Hello and welcome to this virtual meetup titled Save Time, Increase Productivity and Improve Model Governance with H2O. My name is Ivan Trehin and I am on the marketing team here at H2O.ai. I would love to start off by introducing our speaker today. Lauren DiPerna is data scientist at H2O.ai and she's also a developer of Autodoc and she will be presenting today. Before I hand it over to Lauren, I would like to go over the following housekeeping items. If you have any questions, please type them into the Q&A box and we will answer them at the end of the session. And this session today is being recorded. A copy of the recording will be available after the presentation is over. Now I'd like to hand it over to Lauren.
Thanks so much for the introduction, Ivan, and welcome everybody to the Autodoc Meetup. So H2O Autodoc is one of H2O's latest products for automatic model documentation. And in this meetup, I want to go over a couple different things, starting with what exactly H2O Autodoc is, and then highlighting some of the capabilities and features of the Autodoc before jumping into a deep dive of an actual rendered report. Once you understand what the Autodoc is and what the features look like, along with what the report looks like, hopefully you'll feel inspired to generate your own Autodoc. And at that point, I'll show you the Autodoc API. And what you'll find if you're familiar with Python is that the learning curve is extremely low. The Autodoc API really is only 4 additional lines of code that you can tack on at the end of your script. If you're an H2O user, then this means you really just need to go back to your modeling scripts and add an additional 4 lines of code. So to get started, I wanted to highlight the motivation for why you'd want to use the Autodoc. In general, a data scientist, if you are a data scientist, you know this, that a model can take anywhere from a few weeks to a few months or longer to build. And then there's one last barrier once you're done with your model to get your model into production, and that's usually the model documentation. What that looks like for a data scientist, though, is that when they get to their final model, they then have to go back in time and recollect certain artifacts, maybe redo performance metric calculations, gather all of those artifacts, so those would be performance metrics tables and potentially calibration plots. They also have to go back and collect all of the data that they need to provide summary statistics for. So this can be summary statistics for your numeric columns and your categorical columns. It can also be certain plots showing whether or not there's any concerning shift between your training population and your validation population. And once you have all of those artifacts, then you can actually get started writing the report. So instead of having this long process of collecting artifacts and redoing calculations, the nice thing about the Autodoc is that once you're done with a model, you can start immediately with a baseline report. Now, one thing I want to quickly highlight is that the Autodoc is not meant to replace the work of a data scientist. It's really there to enhance it. And the idea is that the report is going to have everything that you need, but in terms of specifics for your use case, that will require the data scientist, as well as deep analysis on the use case and the performance of the model will require the data scientist. So what that means is that the nice thing about the Autodoc is that if you're a data scientist, it's going to save you quite a bit of time. Or if you're managing a team of data scientists, it's going to save data science resources. The reports are also going to be consistent and comprehensive. And what I mean is that you're going to get a report where you know that all of the metrics are calculated in the same way. You don't have to worry that one data scientist is calculating a metric with different calculations than another. You're also getting a very comprehensive report. The way this initial report was designed was to cover the entire data science workflow. So again, you don't have to be worried about one data scientist maybe only focusing on certain sections of their data science workflow versus another data scientist. And finally, the Autodoc is incredibly easy to use, and I'll mention this multiple times throughout the meetup. And we'll also take a look at what the code looks like so you can really get a sense of how easy it is. The next thing I want to talk about, now that you have the motivation for why you might want to use the Autodoc, is what's supported. So the idea of support in the Autodoc is based off of templates and models. We'll start with templates, and then we'll talk about the models. So you can think of the templates as things that the report is things that the Autodoc is going to auto-populate for you. And there are certain file formats that we accept, and then there's certain file formats that we generate. So we'll talk about that first, and then we'll talk about the models. So the Autodoc accepts two types of file formats. These are Word documents and Markdown files. Historically, we decided not to do PDF files because generally what we see is that people want to edit the documents that are rendered. The Autodoc is not the final state of your report, it's just the beginning. Out of the box, you're going to get the Autodoc generic template. So this is the template that we're going to go into in great detail. And this is great because if you don't want to create your own template, you already have a pretty good starting point. However, if you do want to create your own template, we do accept custom templates. So this is basically, the idea started behind the regulatory industries where, for example, banks will have their own templates that the data scientists have to fill out. And what we've done is basically taken those templates, added in different variables, and then auto-populated the content that could be automated. And what this means is that your templates can really be of any size. So you can have a regulatory template that may be, 50 pages long, or you could have a scorecard template, which is about, one-page model summary. And I have sort of an example on the right-hand side here. But whatever you'd like to create, that is something we can work with you to auto-populate. The next part of the support is the models. So the H2O Autodoc was designed for supervised learning models. For the H2O, for H2O3, now H2O3 is H2O.ai's open source machine learning platform, and it does contain both supervised and unsupervised learning models, but the Autodoc is really focused on the supervised learning models. And the Autodoc pretty much supports all the supervised learning models except for a few. So what I'll do here is I'll highlight the ones that we support. So the first one is generalized linear models. So if you build a GLM in H2O3, you can then render a report with that model. Likewise, if you were to build a GBM or build XGBoost model, you can render a report. And we also support random forests both in the vanilla form and then in the extremely randomized trees form. Finally, there's also support for H2O3's multi-layer perceptron. So that covers why you'd want to use the Autodoc, what templates we support, so both Markdown and Word formats, and the models that you can render a report for. Next, I want to highlight the different features that you'll see in the actual report. And the idea here is the report is quite a few pages long, and so I just want to give you kind of an outline of what to expect so you can keep these things in mind as we go through the document. These are also some of my favorite features in the report. So the first section of the report is going to cover your data, and it can include shift detection. So what shift detection is it tells you whether or not there's a difference in distribution between the population that you trained on and the population that you validated on. We'll also provide you with summary statistics. So this will be your standard min, mean, max, and standard deviation summary statistics for numeric columns. And then we'll also provide summary statistics for categorical columns. For the model overview section, we provide quite a bit of information. The two things that I want to highlight are the calibration plots that we provide. So these are really nice because depending on the use case you have, calibration can be quite important. And it's a quick way to verify that your model may or may not need calibration. We also provide performance metrics tables. And these, what you'll see is these are going to be all the performance metrics that are available for the problem type, so regression or classification. And then the last section is the model interpretability section. In the report, you'll have two ways of analyzing how your model works, and that's going to be through feature importance. The nice thing about the feature importance is we actually use the built-in feature importance. So it'll be specific to the model that you've rendered the Autodoc on. And if that model supports Shapley values, we will provide Shapley value importance as well. For the partial dependence plots, they're quite nice because in addition to just a standard PDP, we also provide a histogram directly below, so you can see which values are most frequent in your data set. And with that, I'll start the walkthrough of the report. So what I'm going to do is I'm going to pull up a rendered report and we're going to walk through the document. What I want to highlight here is on the right-hand side, you'll see a code snippet. And this is just your first introduction of what it looks like to render an Autodoc. I also want to highlight that right now the Autodoc is available to all of our enterprise customers, and enterprise customers have access to Steam. So Steam is the way to securely launch and connect to an H2O cluster. And through Steam, you'll have access to the Autodoc, and you'll be using the Steam Python client. However, because this is a meetup, I want our community to know that even if you don't have access to Steam, we're going to be providing access to the Autodoc through a Python package. And so the code walkthrough that we'll do after the document walkthrough will actually be using the Python package. So this will be for anybody who doesn't have access to Steam or won't be using Steam, this will be the code that you will be using. So with that, let me jump to the rendered report. So this is an example of the Autodoc that you would get by default if you were to just run the render Autodoc functionality. Before I start scrolling through this document, there are a few things that I want to highlight. So the first thing is in the table of contents, if you see on the left-hand side, you'll see that there are quite a few sections. And the idea here is that we summarize the entire data science workflow, starting with your experiment overview and data overview, and then including details about the model, which can include the validation strategy, feature importance, and then performance metrics. There's also an additional alternative model section, and this section is quite nice because maybe you've gotten to your final model that you want to put in production, but you've also put in a lot of work verifying that other models don't outperform your final model. So this is the section where you could actually input additional H2O3 models and showcase that they don't perform as well as your final model. There's also the partial dependence plots that we just touched on. So this would be your model interpretability section. It's a way to highlight which features, how varying feature values affect the target. And then finally, there's the model reproducibility section. This is really a documentation section which tells you whether or not your model is reproducible and then how you'd go about reproducing it under different cluster configurations. So with that, the last thing I want to mention before I get started is here on the right-hand side, you'll notice the number of pages. There are about 30 pages in this document, and all of these have been automatically populated. So right out the gate, you're getting 32 pages of technical content without having to write anything, which is pretty nice. So with that, we'll get started. The first section is the experiment overview section. It'll give you a quick two-sentence summary about your model, including what the model type is, so we can see that a GBM was built, and then what it was trying to predict, in this case, default payment next month. Just a little bit of context about the model for this report. The model that was built on historical credit card data to predict whether or not somebody's going to default on their next month's payment. So this is a binary classification problem. And as we can see in this section, which is also auto-populated, we can see that it correctly identifies everything as a classification problem. After that, we can see the performance summary. So this is a high-level summary with AUC for the data sets that I provided in addition to my training data sets. So we have our validation data and then the test set. The thing I want to note about the test set is this is actually my holdout data set that was not used during the model building period. So this is an optional H2O frame that you can provide. After that, you have your system specifications. So anybody who's familiar with H2O3 will be familiar with the H2O.init method, which is one way to start your H2O cluster. This is the output from that table. The only thing I really want to highlight here is that you can quickly see the H2O cluster version and compare it to your Python client version. So the sanity check here would just be to make sure that these two versions are matching. The next section is the data overview section. And again, we talked about this during the slide deck portion of the meetup, but the data overview is going to provide you with a high-level overview of the shape of each of your data splits. So here we have 3 data splits, train, validation, and test, and you can see the different shapes for each of those. After that, we provide you with an overview of your training data. So as promised, these are the summary statistics. It shows you both the numeric and the categorical summary statistics. we can see that the numeric columns, we show you the feature names. So for example, here, as I mentioned, this is a credit card data set, so we can see what the limit balance was, what the ages were, and then we can also see, pay 0 through pay 8. So these correspond to whether or not somebody paid their first month's payment on time or whether they paid it off late. And you can see that at most people are paying 8 months out late. We can also see the bill amount that was paid off, the bill amount that was required, and the amount that was actually paid off. For the categorical columns, we provide you with the number of unique values for each categorical level, and then the most frequent categorical level, along with the frequency of the top value. And you can see the target is categorical, and that it is in fact binary, because there's only 2 unique categorical levels. The next section is the shift detection section. So this section is pretty cool. It just verifies whether or not there's a shift between the distribution of your different data splits. As I showed in the deck, you'll see that in this case, the Autodoc has identified a significant shift detection. And this is in part because I created this artificial shift detection. So I forced my training data set to be on the population of people under 50 and my validation data set to be on a population of over 60. And the only reason I did that was to trigger this feature. And so you can see the drastic difference between train and validation, and then you can see still a pretty drastic difference, but a little bit of overlap here. The next section is the validation strategy section. This section is specific to H2O models. So if you're not familiar with H2O, it allows you to specify multiple different validation strategies. That can be just a vanilla train and valid split, which is what I did here. Or you can also specify that you want k-fold random cross-validation, or that you want your own specific folds through the n-folds parameter. In any of those cases, we would provide that information here so you'd know exactly how the model was validated. We also provide information on early stopping. Depending on the model, you'll be able to parameterize how you want to enable early stopping. So we'll provide that information here. And then we'll also provide documentation for how early stopping works in H2O. And part of the reason that we do that is so that even if somebody who is not the model developer is reading through this report and they're not familiar with early stopping in H2O, they have enough information to understand how it works. The next section is on feature importance. So this section is really nice because it provides you with the feature importance that is model specific. So it'll change depending on whether you're using tree-based models like random forest and GBM, or if you're using a GLM. We also provide you with Shapley values. So as promised, if the model supports Shapley values in H2O, you'll see the values here as well. In the case of the tree-based models in H2O, Shapley values are supported. And this is a GBM, so you'll see the output here. You can see that we provide this output in both table and plot form. And the plot form is nice because it just makes it easier to digest the information. The only other thing I want to point out is that by default, we're going to show you the top 20 most important features, and then we're going to aggregate all the other features together in this category other. What's nice about this is you can quickly make sure that your most important feature is still more important than the rest of the features combined together. So that sums up the data overview, and then we can jump into the final model section. In the final model section, you'll get the model summary table. So this will provide some information about the hyperparameters like number of trees and max depth. And then we'll jump into performance of the final model. So as you saw in the slide deck, the Autodoc does provide performance summary tables. Because this is a classification problem, we're going to show you all of the classification metrics that H2O supports. If this had been a regression problem, we would show you the regression metrics. And this is nice because you can quickly compare these metrics across multiple data splits. Because this is a binary classification problem, we will also show you a confusion matrix. We show this to you again in plot form and also in table form to give you that added layer of granularity. One thing I want to point out is that we do tell you what the threshold value is. So this value is auto-populated. And this is always going to be for H2O, the max F1 score. We provide this information for all the data splits. So again, we provided a validation data split and a test data split. So that information is provided here as well. After that, we'll provide you with the scoring history. This plot is really nice because it's a quick way to verify if your model is starting to overfit. So here we can see maybe that's happening around 10 trees. We also provide you with a quick summary sentence about what each plot you see is about. After that, we're going to provide you with some standard plots that you'd expect for classification, including the ROC curve. So we provide that for validation and test. And then we also provide cumulative gain and cumulative lift. And that concludes the overview of the final model. The next section is going to be specific to the predictions. The first metric that we're going to provide is a metric that if you're in the baking industry, you're probably very familiar with, but you may not be if you're from another industry. So population stability index gives you a sense of whether there's drift going on in your model. And what that means is you are checking whether or not the distribution of your predictions from the training data has changed the distribution of your model predictions for your validation or test data set. We provide a quick summary of what this metric is, and then we also provide you with the rule of thumb, which is that if your values fall between 0.1 and 0.25, you're probably okay, but if you're seeing values that are over 0.25, that indicates a strong shift and you may need to retrain your model. So it just requires a little bit more investigation. In this case, we can see in the summary table that the PSI for both the validation and the test data set is pretty low, so we don't need to retrain the model. I also want to highlight that details on the PSI calculations are in the appendix, and we'll touch on that quickly towards the end. We continue to drill a little bit deeper into the prediction statistics. In this section, we're going to provide you with the prediction statistics per quantile. So what we do here is we bin the data on your training data set and then apply those bins to the other data splits. What you can see in this table is the min, max, mean, and median per quantile. And we provide this information in table and in plot form. Again, the plot forms are always really nice because it makes the information easier to digest quickly. It also is really nice because you can compare the information visually across data splits. So you can take a look at how the prediction distribution looks in your training data set and compare it to your validation data set, as well as in your test data set. After that, we provide you with the quantile response rates. So this is again for a binary classification problem. And what this shows you is the actual response rate per quantile, where the quantiles are sorted in decreasing order. And here, the thing you're looking for in this plot is just a general monotonic decrease. If you see a little fluctuations, that's okay, but if you're seeing big jumps, you might need to go back and investigate why your model is having a hard time predicting certain prediction ranges. The next section is the calibration plot. So we provide this both in the probability and log odds space. The first one is the actual versus predicted in the probability space. And this is really nice because you can quickly see that here the model sort of overestimates and here it underestimates. This shape is actually standard for a GBM, but depending on the use case, calibration may or may not be important to you. As I mentioned, we also provide this in the log odds space if you want to see the values outside the bounded range of 0 and 1. Similar to the PSI, we provide the quantile-based plot calculation table in the appendix if you do need to see that added granularity. So that concludes the section where we cover the prediction, summary statistics, and information. And the next section is specific to your alternate models. For this particular report, what I did is I created a GBM that used the default values from H2O, but you could provide additional models. The alternative models has two sections. It's going to provide you the performance table so you can see how your alternative model performed across data splits. So for train, valid, and test. And then it also includes a parameter tuning table. This is going to be a table of all of the griddable parameters that are available for that particular model. So this is both your traditional hyperparameters and then parameters that H2O, the software allows you to grid over. What you'll see is that the first parameter is going to be the model ID, and then we sort the rest of the parameters in alphabetical order. So this is a pretty comprehensive list, and it might be nice if you do need to try to reproduce that alternative model later on. The last section is the model interpretability section. So it provides you with partial dependence plots. And in this case, I selected the partial dependence plots. You can see that there are 3 user-selected features. But by default, if I hadn't selected them, you would see that we provide you with the top 20 most important features. The first feature that I selected was Pay Zero. So this is whether or not somebody paid off their first month's credit card payment or not. Negative values were that they either had a credit balance, had no balance, or paid it off. If it's, and then the positive values correspond to late payments, so late 1 month, 2 months, etc. The nice thing about the partial dependence plot is that we show you the values that are within the data set, but we also show you out of range values. So the out of range values are represented by diamonds, and in this case, by default, we're going to show you 3 standard deviations out. You can also see a histogram directly below, so you can quickly get a sense of which values of the feature are actually most common in the data set and which ones are uncommon. While there was a pretty drastic jump in the probability of somebody defaulting after the first month's payment is late, we can see that the limit balance has less of an impact on whether or not somebody is going to default. So there is a general decrease the higher your limit balance is in the probability of you defaulting, but it's not that significant. And we can also see here again the distribution of limit balances in the data set. And finally, there's the age feature. This one seems to have very little impact. The only thing I wanted to highlight here is, as I mentioned, I split the data set so that the training data values were less than 50. By default, we will use your training data set to do the partial dependence plots, but you have the options to specify other data sets. And then the second to last section is the model reproducibility section. So in this case, as I mentioned, early stopping was enabled. We saw the configurations for that. But the problem was that I didn't set score tree interval. This is a parameter that's required to make your model reproducible even when early stopping is enabled. And so what you'll see is the early stopping parameters, and then you'll see documentation on how to make this model reproducible given a single node cluster and a multi-node cluster. And what I'll note is this information is available in the user guide, but it's just a nice way to have it all in one place. And finally, there's the appendix. So again, it provides you the model summary details, and then it provides you those calculation tables that I promised. So you can see the PSI calculation table for validation and test. And then there's also the Quantile plot calculation tables. So this can be nice if this is some sort of table that you need to provide to regulators or whoever's reviewing your model. That concludes the deep dive of a rendered Autodoc. What I'd like to do now is show you an example of what the code looks like. So hopefully at this point, while we were going through this Autodoc, you kind of made a mental note of the things that you have to do manually during your own workflow that would be nice to have automated. And we're able to identify how the Autodoc could help you become more efficient. This is the code that you would use to generate an Autodoc. This is a Jupyter notebook that walks through building a standard H2O model and then creating a default Autodoc, so basically using the default settings, and then showcasing how to configure some of the Autodoc settings. So with any Python script, we start with our package imports, and then we kick off our H2O cluster. Now I'll just mention again, the Autodoc is available in Steam, and the Steam uses its own Python client, but here I'm highlighting what it would look like to just use the Autodoc Python package without Steam, just so that many of you who may not be using Steam know that you'll be able to use the Autodoc. The next thing we'll do after our package imports is our data preparation. So as I mentioned, I had that artificial shift in my data set, and you can see in fact that it's here, where my training data set is everybody less than 50, and my validation data set is everybody greater than 50. And then I'll just specify my predictors and response, do some prep that's specific to H2O before building a GBM model. And here you can see the GBM model if you're familiar with H2O. And this is where I actually triggered the early stopping. So if you remember back to the report, one of the parameters for early stopping was stopping rounds, and that was included here. Now for the main part, is creating an Autodoc. What you'll see is, as I promised, only a few lines of code. The first thing is just importing the Autodoc. And then after that, you just need to specify where you want your Autodoc to be saved. In this case, I want the Autodoc to be saved in my current directory, and I want it to be called Autodoc Meetup. So I just will instantiate my configuration class with that path, and then I'll leave all the other parameters default. After that, I'll run the render Autodoc function. So this function only requires that you pass in H2O, your configuration, and the model. And that's because we have an H2O cluster up and running where the training data exists. So this is the simplest form of running the Autodoc. The Autodoc will take a couple of minutes to run depending on how large the data set is, but the nice thing is that we provide you with a progress printout, so you can actually see as each section is rendering and how many sections there are to render. You can see that there are quite a few sections, and these are all the sections that we went over: experiment overview, data overview, and so on. Once this completes, you'll get a printout of where that Autodoc is located. So again, this is just the default Autodoc. You can see that there are very little required parameters, and it's just a few lines of code. The next code that I want to highlight is the advanced configurations of Autodoc. So this is where you have a little bit more control. In this case, I just want to highlight how the alternative model that you saw in the report was a GBM. And as I mentioned, this is just a default GBM, so I'm not really specifying any parameters here aside from the seed. I also imported my test set, so the test set is going to be imported as an H2O frame. And then, as I mentioned, by default, you get the top 20 features for your partial dependence plots, but maybe you don't want to see all 20 features. Maybe there's certain features you're interested in looking at. This is what gives you the ability to say you only want to see, pay zero, limit balanced age, which is what I did. And then to generate the Autodoc, very similar, but we're adding in a couple other parameters. In this case, I'm adding in the partial dependence feature list to my configuration class. And then within render Autodoc, we're now passing in a test set and alternative model. And you can see again, you'll get this printout with all the different sections followed by the path of the Autodoc. And this is the Autodoc that I showcased today. So that covers how to generate an Autodoc. And again, the code is very simple. I'll leave it up for another second. You can take a look at it. And this is all going to be documented in our user guide, so you'll have resources to go back to. And with that, I'll jump back to the slide. So we've completed the walkthrough of both the rendered Autodoc and the code example. And to summarize the workflow in a visual, what you need is your data set and model, enterprise theme to launch your cluster, or if you don't have enterprise theme, that's okay. But what you would do is you'd pass in your model and your data to the Autodoc Python client code, and then it's going to output a model documentation for you. Everything that we covered during this meetup is documented in the H2O.ai user guide. So if you go to H2O.ai under documentation, enterprise theme has its own section, and you'll see this ML Autodoc documentation section. And it'll include all the details about this package along with code examples. And this is a really nice place to start. The last thing that I want to touch on is the H2O Autodoc roadmap. So just a little bit of history. The Autodoc was originally created for driverless AI. Driverless AI is our automated data science platform. And it had, just like you see in H2O Autodoc, a default template that everybody has access to, and then custom templates. After that Autodoc, we developed H2O Autodoc. And for this meetup, I really focused on Autodoc for H2O3, but I will note that it does also support a few scikit-learn models. So if you're not familiar with H2O3 and you use scikit-learn all the time, this package will also work there. We make sure that for Autodoc H2O models, we support all those model artifacts that you can get. So that would be your binary models and your Mojo models, as well as obviously your H2O cluster object. And then, as noted a couple times, we integrated Autodoc with Steam. So for all of our enterprise customers, they can access Autodoc through Steam. But again, in the future, we're going to be providing the Autodoc Python package. We're also developing Autodoc as a service. So that would be a way for you to just upload your model and data and get a rendered report without having to type any code. And so the things that you have to look forward, coming down the pipeline for H2O Autodoc is access to the Python package, whether or not you have a license, support for more scikit-learn models, and then different templates. So in addition to the generic template that we have now, we're going to be building other templates. So maybe if you don't want to have to write the template yourself, you'll still have access to like a one-page summary. And then there's also, we're going to be working towards adding more MLI into the Autodoc. So with that, I'll leave up our H2AI Learning Center slide, and I'll open it up for Q&A.
Great, thank you, Lauren. We do have a few questions that came in. The first one is, how customizable is the Autodoc?
Yeah, so the Autodoc customization comes in two parts. So one is customizing the Autodoc like we showed in the Python client code, where you can configure whether or not you want to see alternative models and whether or not you want to pass in a test data set. There's also more granular configurations, like specifying whether you want to see the quantiles as 20 quantiles or as deciles. And there's some control over the plots and how they're produced. The second form of customization is actually through the templates. So rather than just using the template that we give you by default, you can actually provide us with your own template that you use in potentially a regulated industry.
Great. And someone else asked, do I need Steam to have access to the Autodoc?
Yeah, so currently you do need access to Steam, but the nice thing is in the near future, we're going to be providing access to the Autodoc Python package. And that's really what I highlighted during this meetup, because we know that a lot of our community right now won't have access to Steam.
Okay, do you provide access to the Autodoc artifacts?
Yeah, so that's a great question. Right now, there is a way to get access to the image artifacts, and that would be by, rather than rendering a Word document, to render the Markdown files. So the way the Markdown files work is they actually have the images in their own directory. So that would be an easy way to get access to the plots. But in terms of access to like CSVs of the, Quantile plot tables, calculation tables, that's not something that we have available yet, but we are working towards. And that brings up a good point, which is that if there are any features that you'd like to see in the Autodoc, we would love to get that feedback from the audience if it doesn't already exist in the Autodoc.
Okay. And what versions of H2O is the Autodoc compatible with?
Yeah, so the way that the H2O Autodoc was developed is it's compatible with H2O3 324 and higher. We're also, as I mentioned, we're also compatible with scikit-learn, and that would be 21 and higher for scikit-learn.
Okay, and could you explain how the Autodoc performs shift detection?
Yeah, sure. So shift detection, the way that we do it is behind the scenes, we build a decision tree to predict whether or not a feature record came from the training or validation data set. And then we check if the model is able to easily distinguish which data split that feature record came from. And we base that off of the AUC. And so actually in the background, in the back end, you can configure whether or not you want the AUC threshold to be higher or lower to trigger shift detection. By default, we set it to 0.8.
Okay, and what languages can you generate the Autodoc for?
So the Autodoc is available right now in English, but one of the nice things about having the custom templates is that you could provide us with a template in another language, and then we'd probably have to work with you to translate a couple sections where we're auto-populating text, but that's something that we'd like to start working on so that the Autodoc can be in different languages.
Okay, I think we'll take one last question for today, and that is, can we automate the capture of best practice across multiple models with the same methodology?
Yeah, so that's a great question. And that's kind of the idea behind Autodoc, is that we looked at how different industries document their models, and we try to provide the standard information across those industries in the auto report. So the idea is the auto report provides you with, as much information as possible by default, and then the user can go and decide, okay, for example, population stability index isn't important for my industry, so I don't want to show that section. So they can maybe, delete that section out. But we do try to cover the best practices in terms of what metrics to provide for the model overview, and include things like calibration plus. But in terms of best practices, if there are things that you have that you're using that you don't see in the Autodoc, those are things we'd love to hear back and get feedback from the community.
Okay, great. Thank you, Lauren, for taking the time today, and thank you to everyone who joined us. We will share the recording of this session shortly. We hope you enjoyed it. And we have more virtual meetups coming up. Actually, the next one will be next week on Thursday, and it's a presentation of H2O3 and its capabilities. So stay tuned, look out for the invite, and register. We'll be happy to have you. Thanks, everyone, and have a great day.